Hello. In this video, we're going to start graphing using transformations. This first part of the video is going to be what I would expect you to do if you are doing this by hand. And the last part of the video is going to be showing you how you would do this in, say, MyMathLab or something like that. So, using transformations, graph the parent function following the steps provided in class. Now, in class is what I'm about to tell you right now. To do this, what I want you to do is I want you to identify the parent function. And the parent function here is y equals the absolute value of x. And what I'm going to do is I'm going to create the parent table. Now remember the parent table for y equals absolute value of x, that's available in the notes in previous videos or in your notes if you wrote it down. The x's are -2, -1, 0, 1, and 2. The y values are going to be 2, 1, 0, 1, and 2. If you want to know why, well, go back and watch that video. Now what I want to do is I want to identify the parent functions. The parent transformations. The first parent transformation I'm going to look at is the 2 here. Now, this 2 is outside of the absolute value. And I'm always going to be working left to right here. So that 2 is outside the absolute value. So that is going to be a vertical stretch by a factor of 2. So the 2 is, the 2 is a vertical stretch by a factor of 2. Now, what does that mean? That means that we can create a table for y equals 2 times the absolute value of x. And if it's outside the absolute value or parentheses or anything like that, then it's going to affect the y value. That means that the x values do not change. And if it's on the outside, you do what it says. It says 2 times something, so we're going to multiply the y values by 2. So it's going to be 2 times 2, 1 times 2, 0 times 2, 1 times 2, and 2 times 2. And that's going to give us the new values for the y column. 2 times 2 is 4, 2 times 1 is 2, 2 times 0 is 0, 1 times 2 is 2, 2 times 2 is 4. Excellent. Next, we have this plus 3 right there. Now that plus 3 is inside the absolute value, which means that we're going to look at the 2 times the absolute value of x plus 3. Now that plus 3 is a horizontal, and in this case, because it is plus, that is a shift. But because it is inside, we always use the opposite, so that makes that a -3 horizontal shift. That means that all of the x values are going to have 3 subtracted from them. That gives me a new xy, but notice that since the x's change, the y's stay the same. And then we just do the subtraction. -2 minus 3 is -5. -1 minus 3 is -4. 0 minus 3 is -3. 1 minus 3 is -2. 2 minus 3 is -1. Excellent. Next, we have the -1 there. Now that -1, it's outside the absolute value, so it's going to be vertical. So that will be a vertical, and in this case, addition and subtraction mean shift. And you do what it says. So it's a -1, and it's vertical, so it affects the y values. So that means that we're going to subtract 1 from all of the y values. And that gives me the final table, which just happens to be the original equation in the first place. So really what we're doing is we're starting out with the parent function and we are building up to the actual function itself. Again, if the y values change, that means that the x values will stay the same. 4 minus 1 is 3. 2 minus 1 is 1, 2 minus 1 is 1. 0 minus 1 is negative 1. 2 minus 1 is 1. And 4 minus 1 is 3. Excellent. And so we're going to just graph these coordinates. Negative 5, negative 3. So negative 5, 1, 2, 3, 4, 5, negative 3. There we go. Negative 4, 1. So negative 4. Sorry, it was positive 3, not negative 3. My apologies. Negative 5. 1, 2, 3, 4, 5. Up 3. 1, 2, 3. There we go. Then negative 4, positive 1. Negative 3, negative 1. Negative 2, 1. And negative 1, 3. Then, of course, just connect these with a trusty straight edge. And there is your absolute value. Excellent. Well, that is pretty much it for the handwritten way of doing things. Now I'm going to go ahead and take you to an example similar to this in my math lab. I'll see you there. Okay, here we are in my math lab example. So the question here says, use transformations of the graph of f of x equals x cubed to determine the graph of the given function r of x equals x plus 7 to the third power minus 4. Okay, now if you see this over here and it's kind of small on your screen, you can just click that and it's going to create a larger graph for you to use. That's fine. Now, if we look at this, notice that it's actually telling us what our parent function is. It's telling us that x cubed is our parent function. And notice over here, we don't have a lot of options. We have lines, we have cubics, and we have quadratics. In this case, you'd want to choose a cubic. To do that, let's just kind of plot 0, 0. Always plot 0, 0 for your first point for either the cubic or the quadratic. Now, notice that we have plus 7 right there. That plus 7 is inside with the x, which means it's going to go left 7 units, which is a horizontal shift. So on the horizontal shift, notice that we want to go to minus 7. Notice it's just a scroll bar here. Sometimes it won't be a scroll bar, sometimes it is. But you can kind of see what's happening as you move left and right. The graph is moving left. So go to that minus 7, and that's exactly where it needs to go. Good. Now this minus 4, notice that it's outside of the parentheses here, which means that that is a vertical shift, and that is minus 4, so we actually go down 4 as well. And then there is our actual function. Notice that if we wanted to stretch it vertically, we have that right there. Now, if you go down to 0, it's always going to be a line. Be careful with that. You want to go to 1 if you ever mess with that. And it doesn't have a vertical stretch or shrink. Here, horizontal is right here as well. Again, if you go to 0, it's a line. A reflection over the x-axis is there, and a reflection over the y-axis is there. Now notice that it also does a horizontal shift. So it changes the horizontal shift as well. So just be careful with that. Alrighty. Well, I'm going to go ahead and X there, save that there, and if I check my answer, hey, excellent, I did a good job. I'm happy I did something good. Wonderful. And I'm going to kind of go back to the beginning here. These are kind of put in here sporadically. So if I have x squared minus 5, notice that's quadratic. Let me see if I can find any that have a vertical stretch. Okay, here's a good one. So h of x equals negative x minus 4 all squared. So if I click on here, notice again just the quadratic now. Make sure you click 0, 0. This negative is a reflection, and it's a reflection across the x-axis. So click on the reflection across the x-axis. Notice that it moves it to where it's going down now. Excellent. And then this minus 4 means we go right 4, which is a horizontal shift. Which notice that the horizontal shift here is just a number. I don't know why it's just a number here. So just subtract and then click 4. Did I say subtract? I meant just delete or backspace or whatever it's called. So delete and then press 4. And then notice it doesn't really do anything until you click off of it. I'm going to click over here on vertical shift. And notice that it went 4 units to the right because it's plus 4. And that's what we want because that's the opposite when it's on the inside. Excellent. And then I'll just X off of that, and then I'll check the answer. Fantastic. Same thing here, and then that's pretty much it. Here's one with a vertical stretch. So here the parent function is x squared, which is quadratic. Start at 0, 0. Vertical stretch of 4. So go 4 for the stretch. Horizontal shift of -2. So -2. And then kind of click off of it. And then +1 for the vertical shift. So just 1. And then click off of it. Notice it moved it up. Alrighty. And then just click X and then check your answer. Good job. Excellent. And then pretty much all the others are just identifying the types of transformations. Notice that the square root of x and then -4 outside that means it's the quadratic moved down 4, and only one of these is moved down 4, so the answer here, of course, would be A. Alrighty, and that's pretty much it. I'll go ahead and end the video here, and I will see you in the next one. Have fun.